the connections between a chi-square and an F distribution. Now, we have that if we have a chi-squared y sub p and another chi-squared random variable y sub q, where y sub q has q degrees of freedom and y sub p has p degrees of freedom, where these two are independent, then y sub p divided by p, y over y sub q divided by q is going to be distributed f with p degrees of freedom and q degrees of freedom. So I'm going to show that this result is true. We're going to define W1 as equal to yp over yq, and W2 has just yq. This gives us that yp is equal to W1, W2, and y sub q is equal to is equal to W2. Our Jacobian then becomes, so we take the derivative of yp with respect to y1 and we get W2. Derivative of yp with respect to W2 and we get W1. Take the derivative of y sub q with respect to W1 and we get 0. Take the derivative of y sub q with respect to W2 and we get 1. So this becomes the absolute value of W2. Now the density of y sub p, y sub q, these are independent random variables. So the density of this is just two chi-squared densities times each other. So we have 1 over gamma p over 2, 2 to the power of p over 2 times y sub p to the power of p over 2 minus 1, e to the power of negative y sub p over 2, 1 over gamma q sub 2, 2 to the power of q divided by 2, y sub q to the power of q over 2 minus 1, e to the power of negative y sub q over 2, which becomes 1 over gamma p over 2, gamma q over 2, 2 p over 2 plus q over 2, y sub p to the power of p over 2 minus 1, y sub q to the power of q over 2 minus 1, e to the power of negative yp plus yq, and all of this is in parentheses, divided by 2. This means that f of W1, W2, W1, W2 is equal to, I'm actually just going to copy this component up here so I don't have to keep rewriting it. And put that gamma back, that gamma sign right there. And then we're going to substitute W1 and W2 in the appropriate spots, which becomes W1 times W2 to the power of p minus 2 minus 1, W2 to the power of q over 2 minus 1, e to the power of negative W1, W2 minus W2, all over 2. This is actually a plus. I'm going to copy this constant again. then I actually have to include the Jacobian over here, so times W2. So then W2 to the power of P over 2 plus Q over 2 minus 1. So this is to the power of 1, so one of these negative ones cancels out. Then we have W2 to the power of P over 2 minus 1, e to the power of negative W2 over 2, W1 plus 1. Then if we want to find the density of W1, FW1, W1 is equal to the integral of the entire support of W2, which was from 0 to infinity. Again, we take that constant, bring it down, it hasn't changed. W1 is treated as a constant in this case, and this should have been a W1 right here. So W1 is treated as a constant, P over 2 minus 1. So this whole component is a constant for now. W2 to the power of P over 2 plus Q over 2 minus 1, e to the power of negative W2 over 2, W1 plus 1, dW2. Now we can see that we have a kernel of a gamma distribution. So this is a kernel of a gamma distribution with, with alpha equals P over 2 plus Q over 2, and beta is equal to 2 over W1 plus 1, which means we're going to take our constant, it's going to stay the same, and we have that other component, which is W1 to the power of P over 2 minus 1. Now from the kernel of the gamma distribution, we have gamma P over 2 plus Q over 2. And then we have the beta parameter, so this would be 2 over W1 plus 1 to the power of P over 2 plus Q over 2. Then we can simplify this a little bit, so we have P plus Q over 2 over our constant, which is gamma P over 2 gamma Q over 2. Our 2 to the power of P plus Q over 2 actually is going to all cancel out, so then we just have W1 P over 2 minus 1, and then we have 1 over W1 plus 1 to the power of P over 2 plus Q over 2. Now we aren't quite done. We didn't solve the whole thing. Now we're going to do another transformation. We're going to call W is equal to W1 Q over P, which is going to be the actual F distribution that we're looking for. Once we do this, we see that F of W is equal to gamma P plus Q over 2, gamma P over 2, gamma Q over 2, W1 P over, not W1, just W, P over 2 minus 1, Q over P, P to the power of 2, and then we have 1 over 1 plus Q over P, W, P plus Q over 2.